Ja, hallo, ich bin Sergei Golubchik und das ist mein Vortrag auf Englisch. Das heißt Duel the Talk. So at first I called it Duel, but Duel by Sergei Golubchik, it looked like I created this language, which is, well, incorrect. The Duel as a language was invented by Michael Golan, I don't know who he is, never saw him, in 1993, and he implemented it as a patch for GDB, which was 4.6 at the time, and he put it in public domain. Unfortunately, it never got into, well, GDB itself, for licensing reasons. GDB developers wanted to accept only GPL code, so he asked him to put it under GPL, and he didn't like GPL, so he said it's public domain, you can just do whatever you want with it. And they said, no, well, our lawyers said it's not good enough, you need to explicitly say it's GPL, and it never was in GDB. Despite the fact that even GDB developers, and I've seen the email, was saying that it's insanely cool. It's a quote from the email, but it was never in GDB. And my first encounter with that was in MySQL days in 2002, when I was tasked with fixing some, don't remember which bug in MySQL on SGI IRIX, which was my first and last encounter with IRIX. I SSH'd there, and in GDB I saw a strange command called DUEL, looked for help, and it was, well, pretty nice for examining lists and arrays. Yeah, I thought it's a cool thing that IRIX has, and then forgot about that. Then I recalled that in like 6 years later, discovered what I just told, that it's a patch for GDB, not some cool IRIX feature, and the GDB won't take it. So I'm using Gentoo on my laptop and did it for many years. So I just ported patch to GDB 6 at the time and sent it to Gentoo maintainer of GDB, and he accepted it. And for the year, I was enjoying GDB that had support for Duel in Gentoo, at least. I didn't care about that other people didn't have it. But then Gentoo moved to GDB 7, the patch didn't apply, and they threw it away. I tried, it was difficult to apply, and then I forgot about that again. And then 8 years later, I thought about that again, digged it up, and by that time, GDB had a Python API. So I re-implemented Duel completely in Python using arpeggio parser and GDB Python API. And since then, it works as I was upgrading GDB over and over, and they keep the API stable, so it doesn't need any changes anymore. It just works as GDB progresses. So let's start from the. I'll be showing on examples of what everything Duel can do on a small example program. So this is just doesn't use any secret data structures. It's total libc from the man pages. It calls scandir to get the list of all directory entries in the root directory, and then it does get other info to resolve this host name, which I was just trying to resolve Amazon.com, and I've seen this somewhere in the output, and I needed an IP address that has, I needed a host name that resolves to many IP addresses, IPv4 and IPv6. This was a good example. So nothing particular magic about this one. And if you read the man pages, you'll see that scandir allocates and returns an array of dir end structures and terminated with a null pointer. And get other info returns a linked list of other info structures. This is what I'll be using in all my examples. So let's first see what we can do with the arrays. So after executing, going step by step to execute scandir, I can look, for example, for the first two names in the dirs array, and not surprisingly, it's dot and two dots. And then I can see, so this is easy, you can see I just specify a range, otherwise it's a normal C syntax. And then I can look at all entries telling Duel to start from 0 and go without specifying the upper limit and stop at null pointer. And then again, for every element, I print dname, which is directory name, and then I can print this way the whole array in one command. And with the linked list, so after stepping down few more lines to execute getter info. This is how I would usually see the results of the get other info. So I use p command, print p others, and then I print AI other for the first element. Then I add arrow AI next, and then I print the second element and the third one, and so on. And then I get bored in the element number 6, and there are more of them down below. And in Duel, I can do all that with just one command. So I use Duel command, start from the others pointer, and then this long arrow says that you need to follow the list, traverse the linked list using the AI next pointer. And for every element, print AI other, and then I print the whole list with just one command. So the main thing, as you have just noticed, that's the main idea where the ideology of Duel lies, that an expression can return many values. So unlike C, where you have expression 1, plus, then expression 2, then you put plus in between, and then you get still one expression with the result 3. Every expression has one value. In Duel, an expression can return many values. Like in this first simple example, there's one expression with two values, 1 and 2, and then the second expression with two values, 100 and 200, and I put plus in between, and it tries all the 4 combinations. So I get an expression with 4 values, with, well, all the possible combinations. Or the second example, there are 2 strings and there are 2 indices, so it applies every index, well, square brackets expression to operator to every string, and then it gets an expression with result with 4 values. The main syntax of Duel is built on C with a few extensions. So generally, it's easy to go from C syntax and from the normal GDB print command to Duel. Like here, if I would want in GDB print the just normal first element of the array, I would do it like this, p, dir, square brackets, and so on. And if I want to print more than one, I just replace the one value with a range, and I replace p command with the Duel command, and then I can print more than one element. And again, I can print more than one value for every element of the array. For example, I can print the inode and the name for every element from 0 to 4 for the first 5 elements of the dirs array. This also works well, as one would expect. And the same for linked list. So this is a p command to print the first element of the linked list, and then replace p with Duel and tell the Duel what pointer is used to traverse the linked list, and the Duel will traverse the linked list automatically, printing, well, IP address for every element of the array automatically. So, yeah. So what I want to say now, so if basically you get bored and you want to leave right now, this is the thing you need to remember. Everything else is just helpers, convenience operators, advanced features. This is the main thing. So expression in Duel can return many values. That's the main thing to remember. Conventional C operators then work on every value, and if it's binary operator, it works on every combination of values from the left operand and right operand. And if you use question mark, colon, then it'll be a combination of all the 3 possible values. There are 3 ways to generate an expression that returns many values. You can literally list all of those values explicitly comma separated. You can use a range, and you can use a linked list traversal starting from the root of the list, which is A, and then using pointer B to traverse the list. And of course, you can combine them. For example, if you start from the root and you will traverse by using 2 pointers, left and right, this is how you traverse the binary tree. So it'll do root, root left, root right, root left left, root left right, and so on. They are all naturally combined because they're just operators. So now let's look at those operators in more details. So this is, again, the range, and that's how you print the, well, all command line arguments. That's argv array, start from 0, you go till argc -1, and it prints all elements. This is literally what one would expect from this expression without knowing anything about Duel. Because the syntax going from 0 to length -1 is so common. There's a special shortcut for that, where you don't specify the first element and you specify just the length. It's exactly identical to the previous example. Without first element and until argc means literally from 0 to argc -1. And a third way of printing all the command line elements, it's a little bit trickier. So this is an example I already had before. This is an open range. It starts from 0, it then goes, well, till infinity, just keep generating values, but it stops at the first 0 pointer. This is not exactly the same as first two examples. Well, normally it is, because argc tells where the first null pointer is, but if those argc and argv were inconsistent, then they might have printed different values, which, well, doesn't usually happen in real life, but with the dirs array in the example program, there's no length. I just need to print until the null pointer. So let's look a little bit closer at this at 0. This is not something you put at the end of the expression always. It's just an operator, which is at, and there's something that generates values on the left and termination condition on the right. So I can use this expression, or I can use this operator in the middle of the expression just as well. It doesn't have to be at the end. As in the example that I've already had before, I start from this dirs array, from a 0 element. I print the whole array until the null element, and this will print pointers to the dir end structures. And then for every dir end structure of the array, I resolve the pointer and I get the dname element, and that's how I print all the names of from the dir end structures in the dirs array. And even more, looking at the until operator, at 0 is not a full syntax, it's just a shortcut. The full syntax is, again, there's something on the left that generates values, and there's expression on the right, and values are generated until this expression is true. Well, that's why I call it until operator. And looking at the linked list example, you might remember that first it printed a few IPv4 addresses, then it started printing IPv6 addresses. And what if we just want to see IPv4 addresses and stop before the first IPv6 address? This is what it's doing. Do I have a mouse here? Oops, no. I'd better. I shouldn't have been doing that. Yeah, I'm sorry. Yeah, it works. So, yeah, where was I? Yes. So this traverses the linked list and until the AI family, and underscore in this context is the current element, basically. Until the AI family of the current element is IF in at6, so it'll only see IPv4 addresses. And again, this is used in the middle of the expression. Then it resolves every pointer and prints AI header of it. So it prints all the IP addresses, which are IPv4 addresses, until the first IPv6 address. And at 0 is literally exactly the same as at underscore equals 0. That is, it traverses the array until the current element equals 0. But simply because it is such a commonly used syntax, it's in all the examples, you already seen many examples below, and this is what I actually practically use the most often. At 0 is used very often, so there's a special shortcut for that. You don't need to specify underscore equals 0, just write at 0 as a special shortcut, but this is the full syntax. Now there are filters as well, so until is not the only operator in DUEL. Let's see, so get other info returns a set of other info structures for different socket types, like for TCP, UDP, and RAW. And let's say we only want to see the raw socket entries. We can, of course, print sock type for every, traverse the list, print the sock type for every element, and then compare with the sock raw, and it'll work as you might expect. So it will print 1 where, well, the sock type equals sock row, 0 where it's not equal sock row. So that basically works. But it does kind of has a lot of garbage on the screen. I'm not interested in elements which are not equal to sock row. I'm only interested in elements which are row sockets. So I don't need just normal comparison. I need more something like grep that just doesn't show me the rows with no match. And this is done in Duel. You just add a question mark to the comparison operator. And it works also with, greater than, less than, non-equal with anything. You just put question mark at the end. Then it will work like filter or like grep, and it will show all the matching rows. It does not show the result of the comparison because there will be just 1 in every row. It wouldn't be particularly useful. It shows the expression on the left of the comparison operator. In this case, it shows 3, which is the value of sock row. But if you'd had, I don't know, less than, then it might show different values. But it shows only rows that satisfy the expression. And then I could see that sock row elements are element number 2, 5, 8, 11, and so on. And this syntax with double square brackets, it's not just a useful shortcut that it uses when printing. It's actual operator in Duel, which means if an expression returns many values, take value with this index. So I can literally write others long arrow I next and take the element with index 2 starting from, it's count from 0, so it takes the third element in the linked list. And they then print its IP address. So this works. And again, 2 is just an expression, so I can put any Duel expression inside. I can select many elements. And this is not, as a small extension, which is more Pythonic and not C, I can print the last element in the list, or, well, second from the last by using negative numbers, which count, well, from the end. So this is the last element. And one very artificial example, again, to illustrate how double square brackets work. This is first, so I take it literally lists numbers from 1 to 7. This is an expression that has 7 values. Then I print values number with index 2 and index 5, that is 3rd and 6th, and it works exactly as you might expect. Then curly braces. So back to the example I've just had, printing the last element from the list. It works, and it does print the last element of the list. Otherwise, I wouldn't have it on the slide. But the element number, it's shown as -1 because, well, Duel normally just prints the expression you've written on the left side of the equality sign. And I would rather prefer to see the actual index of this element. And for this, I can use curly braces. So I put curly braces around -1, and then I see that the last element is element number 26. And to illustrate better what curly braces do, this is a simple example. So if I just write Duel 1 plus 2 plus 3, it'll print the expression I written, 1 plus 2 plus 3 equals, and then the value 6. If I put some part of the expression in curly braces, it will first evaluate this expression. It's like early evaluation. And then it'll print the result on the left, 1 plus 5, and the actual full result on the right. So -1 technically means length of the array minus, well, 1. So when I put -1 in curly braces, it shows me, it evaluates it early, it gets the length of the array -1, 26, and that's how I see the last element is 26. In all the Duel examples that I have in the manual, curly braces are really only used, or almost only used, inside indexes when you evaluate indexes and you want to see the actual index and not the complex expression. Duel can do aggregations as well. If you have an expression that returns multiple values, // at the beginning will replace all those values with the number of values. So I can easily calculate the length of the linked list or number of elements in the dirs array, which I get the whole dirs array until null pointer, and I can calculate the length of the array. And +/, it does a sum of all the integers. I'm not quite sure what dreclen means, but it looked like something that makes sense to add up together. So the sum of all rec lengths would be, well, 528. And that's one more useful operator. And I'm getting actually close to it's short talk, I'm getting close to the end of the dual features that I wanted to talk about. Back to the example I've already had when I print all the elements that correspond to row sockets, which is, well, good, it works, but I don't really want to see the sock type for every element that has a type of the row socket, because I already know it, well, it'll be 3, it'll be sock row. So this 3, it's not particularly useful. What I want to see the IP addresses for all those elements. And one thing would be to write down all those indexes and then look at the specific elements in the list. But I can also do like this. And this means for, well, after filtering on the sock type, instead of the sock type, print the AI adder. And this way, I can immediately see IP addresses for all the elements in the linked list that have the socket type corresponding to row sockets. There are a few more exotic features that Duel has, and I've implemented, but practically, I don't think I've ever used them. So I'm not going to talk about them, not to not confuse you. Everything I had on those slides are features that I'm actually using, well, when I'm debugging in GDB. So that was it. Where you can get it, it's in PyPI, so you can install it with pip. Just need to enable by putting import duel into GDB init, or you can clone it from GitHub. And yeah, fork, create pull requests, report bugs, everything. And because this was such a short talk, so this is repository GDB tools. It has 2 modules. One is Duel, and there are bonus slides because we have time about Pretty Printer, which is a second feature in GDB tools GitHub repository. So if you do pip install GDB tools, you'll get both. Yes.
Maybe a quick question to Cool first, because it kind of covers the same, but actually the topic is Pretty Printer. So, like, if I do a DL instead of a print, it just gives me the normal GDB print. So now if I want to put a modifier, just a simple example with a print/x for a hexadecimal output, how do I pass that to Google?
No, you cannot. That's actually a feature request in GitHub repository. Okay. I'm showing the sign, please repeat the question. And the question is, so you can see here there are /something modifiers after the p command, and the question is how to pass this to Duel. So it wasn't in the original Duel. There was quite a few stuff that weren't in the original Duel. And that's a feature request for that in the GitHub. And I was so far replying that I don't know how to do that. I mean, conceptually, because Duel can return many values. And it can return strings, numbers, and everything in just one command. And it's not exactly clear how to apply modifiers to everything together. So if you come up with a concept how they should work in Duel, you just go to GitHub, add a comment under the feature request, and then I'll do it. I just don't know how they should apply, how they would work. I think that was it. All right, so pretty printers. You might have seen that all those examples when I print IP addresses, they look like this on the top. And normally when almost everybody else would print an IP address, they would look like this, the second line. I used p/r, and /r means raw, it disables pretty printers. This is how sock adder structure looks like, and it's not easy to read. If you use /u, which means unsigned, then it'll print the string as unsigned numbers. And if you look carefully, you can see the IP address here. But this is because SA family is 2, which means IPv4 address. If it would be 1, I think it'll be a socket a Unix socket, there should be a path name somewhere. If it would be 10, it'll be IPv6. And part of the IPv6 address would be beyond the length of the string, so you wouldn't see that at all. So the correct way of printing a socket address structure is to look at the socket family, and then the family defines how long the string actually is and how to interpret the data. This is not that GDB can do for you. Luckily, GDB has a concept of pretty printers and pretty printing Python API. So you can write small modules, some small classes in Python that interpret your data and print them in some way you want them to be printed. And this is what the official Python API look like. And this is what some string function from inside MariaDB just has a pointer and the length. And this, so I selected with yellow the line that, well, actually interprets the data and prints them. Everything else is just boilerplate code according to GDB printing API. I need to create a class, a constructor that remembers the value, then create a register collection, add printer specifying the class name 3 times in the add printer line, and then register it. And I actually hated it when I was writing my second printer. So I removed all that and created a printer decorator. And all my printers that I have locally, they look basically like that. So I just one function with the name of the type you want to print, and then the actual code that prints it. This is so printer decorator is also part of GDB tools. So if you install GDB tools, you'll have printer decorator, and you can write your own printers to print the data structures. And just to end this, this is the printer that prints the socket address structure via IP addresses. I'm not going to explain every line of it, but you can see at the beginning there's printer decorator. Then there's a function with the name sockadder because it prints socket address structure. Then it checks the family if it's 2. Then it prints 4 decimal numbers, and if it's 10, it prints 8 hexadecimal numbers. So that's why when I print socket address structure, I just get nicely looking IP address or IPv6 address. And then, so I need to write it once, put in my GDB init, and then I forget about it, it just works. So that was the second part, which is that you will get if you install GDB tools from this GitHub repository or from PyPI. Oh, well, that was it. Do you have any questions? I actually have all of that live. I can also demo it in GDB if you'd like to. Let me see if I have. If I couldn't do that. It doesn't grab the focus. No. Still doesn't have the focus. Yeah, but if you have any questions why I'm trying to enable this, just please go ahead.
So you know, is dual package in any of the standard Linux distributions?
No. It's in PyPI, so you install it with pip, not with your package manager. Yes, and yeah, I can print all those things. So it prints all the addresses, and if I resolve it, it'll be like dname or something. Yeah, it'll print all the names, and well, it does exactly what I've just shown you on the slides. So are there any questions? Or do you want me to try some command or anything? Okay then, thank you.